area of the green square that is inside the triangle whose dimensions are 3, 4 and 5, as you can see in this given figure. As we can see that this triangle is in a ratio of 3, 4, 5, and any triangle whose sides are in the ratio of 3, 4, 5 is always a right triangle. So therefore this given triangle is indeed right triangle. That means this angle is 90 degrees. So let's go ahead and examine this figure furthermore. Now in our very first step, let's focus on this green square, and here's the definition of the square. All sides have equal lengths and every interior angle is 90 degrees. That means right angle. That means this angle is 90 degrees, this is 90, these all are right angle. Then we can conclude that this angle outside for this white triangle is going to be 90 degree as well, and on this side, on this left hand side, this triangle is also going to be 90 degrees. And furthermore, let's go ahead and label these points. On this vertex of this triangle, I'm going to call A, this vertex B, this vertex C, and this point I am going to call D, this point I am going to call E, this point F, and finally this point G. And here is our much nicer looking figure. And here is our next step. Let's focus on this right triangle ABC. And here this angle is 90 degrees, as you can see. I am going to call this angle alpha and this angle beta. And we know that the sum of these all three angles must be 180 degrees. So that means alpha and beta are complementary angles. And here's the definition of complementary angles. Two angles are complementary if they add up to 90 degrees. And in this next step, let's focus on this right triangle AGD. And we know that this angle is alpha and this angle is 90 degrees. And furthermore, we know that the alpha and beta are complementary. So that means this angle has got to be beta. And furthermore, let's look at this right triangle FBE right up here. And as we can see that this angle is beta, this angle is 90 degrees. So the complement of this beta is going to be alpha, because we know that alpha and beta are complementary angles. So therefore, we conclude that this triangle AGD, this one, is similar to this big triangle ABC according to this angle theorem. And furthermore, this right triangle FBE, this one is similar to this big triangle ABC as well according to the same angle theorem. Now let's look at this next step. Since the triangles AGD and this triangle FBE are similar to this big triangle ABC, and we know that the sides of this big triangle ABC are in a ratio of 3, 4 and 5. So therefore we conclude that the sides of these triangles AGD and the triangle FBE are also in the ratio of 3, 4 and 5. And in this next step, let's focus on this green square once again. And let's assume that each side of this square is x unit, x, x. Let's focus on this triangle AGD once again, and we are looking for the value of this side AD. All right, so we want to find the value of this side AD of this triangle, and we also know that this side of this triangle is x units, and this side is the hypotenuse. And here I have copied down this triangle AGD right over here, and we know that the sides of this triangle are in the ratio of 3, 4, and 5. No wonder I put down 3x, 4x, and 5x. And we are going to calculate this side, and we know that this side is our hypotenuse, and this side is right over here. And since we know that this side is x units and here it is 4x, we can make it x by just dividing 4 across the board. If we divide this one by 4, we're going to divide this one by 4 and this one by 4. So therefore we can see that this side turns out to be x units, and this is going to be our side that we were looking for. So that turns out to be 3x divided by 4. In this next step, let's focus on this triangle FBE, and we want to find the value of this side. And here I have copied down this triangle right up here, and once again the sides of this triangles are in a ratio of 3, 4, 5, and we are going to find the value of this side, and this is our hypotenuse. In this case, this is our hypotenuse, and this side is this one, and as you can see, this side is x unit, and here we have a 3x. We can make it x by just dividing 3 across the board. And here you can see that this side turns out to be 4x over 3. That means this side is going to be 4x over 3. Now in this step, let's focus on this side AB. We know that this side is 5 unit, and we can see that this is the sum of this part plus this part and this part. If we add them up, that is going to give us the whole thing is going to be 5. Therefore, in this step, I have just copied down 3x over 4 plus x plus 4x over 3 equal to 5. And now let's go ahead and remove these fractions, and we can see at the denominator we got 4 and 3. So the least common denominator, or sometimes we call it least common multiple, is going to be 12. So let's go ahead and multiply across the board each and every term by 12 to remove this fraction. So now this 4 goes into 12 3 times. 3 times 3 is 9x plus 12x plus 3 goes into 4 times. 4 times 4 is 16x equal to 60. If we combine all these like terms, we are going to get 37x equal to 60. That means our x value turns out to be 60 over 37. So thus each side of the green square turns out to be 60 over 37, and now we are going to calculate the area of this green square. And here's the area of the square formula, a equal to s square. So that means in our case, a equal to side is s is 60 over 37, and we are going to square it. So that is going to give us 3600 on the top divided by 1369. 9. So thus the area of this green square turns out to be 3600 divided by 1369, or that is approximately equal to 2.63 square units. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.